Hello and welcome to Ask the Experts, the show where you can connect directly with the experts to get your questions answered. I'm Graham Bury, and today we're here to talk about confidential computing. Uh, I have joining me Michael McReynolds and Amar Gowda. We're all part of the Azure Confidential Computing team. If you're joining us live, please leverage the chat to ask any questions. And if you're watching on demand, then welcome. Be sure to check out the resource provided in the description so that you can learn more. So let's get started in terms of what we just had at Microsoft Build 2022. We had a great showing of some of our new innovations with Azure Confidential Computing. We had the GA of our Intel SGX-based DCSv3 virtual machines, as well as some new innovations in the container space. Just to get us coordinated with what happened at Build, Michael, do you mind giving us some reference as to the new virtual machines that we just announced GA?
Sure. So we've been investing in Intel SGX for a number of years now. We previously went general availability with the DCSv2 in 2020, and we heard a lot of feedback from customers with regards to some of the performance constraints of that virtual machine series. So at Build this year, we announced the DCSv3 series family, and they're a substantial lift on the prior generation. We increased the compute performance 6x. We increased the memory 12x, and we increased the EPC, which is the encrypted portion of memory where customers can run their SGX applications by a factor of 1500x. So pretty transformational and really timely, because we've had a lot of customers asking for this. And right now we're focusing on broadening availability. We just recently launched in Japan and Switzerland, as well as another of other markets across the European Union and the United States. So Build was really about celebrating that and making these available for our customers.
That's really cool. Thanks, Michael. And if you're not familiar with confidential computing to begin with, I'll give a little bit of an overview. So Michael referred to some of this encrypted memory in these VMs, and that's really where confidential computing shines. There's this new innovative hardware that we have available in Azure, and it allows you to go with a stronger defense in depth with workloads moving to the cloud. This is where you can protect your data even while it's processing in this memory. As Michael mentioned, it has this encrypted memory that it comes with data confidentiality, data integrity, and code integrity. And customers are always in control of their data when it's running into the cloud. So we can go beyond the mechanisms that we have today to protect data in transit and in use. In transit and in storage. And now we can also protect data in use while it's running in the public cloud. And this can be a big innovation to enable more customers to move to the cloud. So Amar, give me some perspective in terms of where customers are coming from, what are they trying to do to stay in control of their data, and how can confidential computing really help there?
Yeah, there are a couple of kind of compelling reasons we see customers coming to ACC looking for, right? So one most important thing is I want to protect the data in use, either because the customer wants to reach high privacy goals, or is driven by compliance and legal and defense in depth related requirements, right? Those are the driving factors customers coming to Azure looking for the solutions. Extending to that, there is also about the code integrity and the data integrity piece, which is critical, right? How do you trust the execution environment? How do I establish trust remotely so I could execute the code in a secure environment and kind of share credentials or like PII data to do further computation at scale in Azure, right? That's how customers look and keep coming to Azure. And data analytics, confidential ML training, as well as securing with enclaves for crypto operations like tokenization. Those are all the common scenarios customers come to Azure.
And we're getting some questions about these enclaves. So in terms of how we can go and protect data, this is general compute that we're talking about, where workloads can come and process. And Amr, you referenced around attestation and customers being able to verify. So can we just go one step deeper in terms of what it means for a customer to stay in control of their data and have that full verification with attestation?
Yeah, absolutely. Right. So attestation in confidential computing really goes down to the execution environment and what makes up the execution environment. You have the core, which is the CPU and the chipset where it's executing. You have the firmware version and the microcode version, and you have everything else that makes up your trusted computing base. So the whole what makes up your trusted computing base, that includes also your software that is running there, right? The whole of that stack is what we call a way for you to verify this is exactly what you intended to run and meets your security bar, or a level that allows you to execute or change credentials. So you could do that with another app trying to do an attestation or challenge the server app where this is getting executed, for example, an enclave. You could also sign the code and check if this is exactly your signed code that is executing, which will be reflected in your attestation. So we also have Microsoft Azure Attestation Service that helps you to really verify if this is a genuine uh, Intel SGX chipset and not tampered and meets the minimum security bar set by Azure and Intel. And this also applies to AMD stack as well. So overall, this is like remote guest attestation. You could check and execute. This allows you to kind of trust the system and nothing has been tampered all along when it is running.
Awesome. And I want to build on a couple of things. We did see a question from Stevie come in there about the secure enclaves and meeting different levels of compliance. So logistically, this is infrastructure in terms of virtual machines and containers. And really, the compliance needs are typically met at our service layers. And absolutely, this infrastructure is leveraged for our managed HSM services, as well as other services that do meet FIPS compliance there. Um, Amr, you mentioned a couple different aspects of hardware solutions and bits. So I'm going to throw this one over to Michael. Can you help clarify when we talk about, application enclaves with SGX and that level of confidentiality and security control? How does that compare to, the different offerings that might exist? Amr made a reference to AMD as well. So help us understand to disambiguate between the different offerings.
Sure, we have two. Sure, we have two offerings today that are in market. One is based off Intel's software guard extensions, or SGX, and the other is based off AMD's SEV S&P, that stands for Secure Encrypted Virtualization, Secure Nested Paging. And the real benefit of both of these technologies is it enables you to uh, obtain a trusted computing base that is extremely tight. One of them optimizes more for lift and shift, whereby you can encrypt your entire virtual machine without any changes to your application. So that's using the AMD technology. The benefit of that is it enables you to easily migrate to the public cloud and be able to not have to make any application changes. Your guest administrator is still within your trust boundary. So that's one piece. The other piece is these SGX technologies, which have this EPC memory. And what you can do as an organization is take your existing applications and either you can containerize them and run them in the enclaves, or you can rewrite your application to take advantage of this enclave. And you can protect even your most sensitive data from even yourself if you wanted to kind of proceed down this path whereby you want to only ever algorithms can see that data. So that it's two approaches at being able to give you confidentiality. One is confidentiality from even yourself, and the other is confidentiality from just Azure. So we're making both these tools available for organizations because we see that organizations have different challenges that they're trying to solve.
That's excellent. And Michael, I know we talked to lots of customers, and it ends up being that first question that says, "Hey, do I have to get into app development?" Some customers are very open to that, but then that can be a barrier for many. So we've started working with this rich ecosystem of ISVs and partners that have solutions already developed in order to leverage this Intel SGX infrastructure. Amr, do you want to give a couple examples as to what types of solutions exist with ISVs and partner solutions?
Yeah, so one of the top solutions ISVs offer here is like Intel SGX has a programming model, right, for a reason, and that programming model really is about the constrained execution to the machine or the kernel and the kernel level below, right? So there is a constraint on what you can run. So we have plenty of ISV solutions who offer what's called as a lift and shift experience, where they remove the need for you to refactor your code and just bring your container or your app, like a Java app or a Python app, to run as is, right? That's a whole set of solutions that ISVs offer today in Intel SGX. An extension to that, we also have some key management solutions and folks who are trying to achieve very high isolation and security and even meet some compliance using Secure Enclaves. That's a set of solutions. And the third one is kind of more vertical industry solutions around the data analytics space, right? This is about federated ML learning or doing ML training with non-anonymized, non-masked PII data, but still meet the privacy requirements and the compliance requirements around the data type that is being handled. So this extends to the data clean rooms, for example, where multiple parties are coming together to compute confidentially. Obviously, that's a hero scenario we see, right? So we live in a world where there's so much of data, and every company is trying to monetize on the data, but they could only do so much with the data of their own. Now, this is about collaborating beyond the boundaries, beyond the organizations, and gaining insights, business insights that drive next set of business decisions. This is a very high adoption area for confidential computing generally.
I really like that type of use case. So if there's anyone watching that is working with sharing data across companies, we're very curious how you do this today. And I think a couple different concepts were brought up there just while you were speaking, Amr. Both the notion of multiple data sets coming together, multiple organizations working together to combine data and tackle problems that no company could do in isolation. Just a couple examples. We have customers, multiple banks that are competitive banks, pooling together data in order to tackle fraud and money laundering that is, across industry scale of a problem. Same within healthcare. We have great partners and customer solutions in order to pool together larger data sets that are very PII and regulatory controlled data in order to move that to the cloud, bring it together from multiple data providers, and have bigger data sets to optimize and have much improved insights off of model development as well as inference and learnings from the data. The question around certification popped up in this in the chat as well. The biggest thing is around some of these multi-party type scenarios. So Michael, maybe can you reference where we're seeing a lot of customer conversations, especially from the EU, in terms of meeting compliance and regulatory needs?
Sure. Yeah. So ACC is a great capability to try and help you comply with the ever-changing regulatory landscape. And the EU is one area whereby, with the introduction of GDPR and Schrems 2, we're seeing a lot of customer traction whereby organizations are looking to ACC to try and help them comply with the ever-changing landscape. Azure is, public cloud and has a lot of certifications which make us one of the most compliant cloud service providers out there. So I would say we don't have anything specific for ACC today, but what is happening is ACC is enabling us to unlock new conversations that were not previously possible. A big one that's happening at the moment is this notion, and Graham alluded to it, of an organization building an AI model and wanting to protect that intellectual property because there's a lot of investment that's put into that. And we recently announced a preview of the confidential GPU program with NVIDIA. So we're seeing confidentiality starting to span both the CPU vendors across Intel and AMD, but we also starting to see it etch into GPUs for more AI inference and AI development. So that's a really cool scenario, and we're really excited to be able to help organizations compete and secure their models around the world.
That's great. Thanks, Michael. And really, that's where we're seeing customers come and leverage ACC for multiple aspects. Some is to get the defense in depth that says, hey, I want to have the top of the line security against the ever evolving cyber threats and things like that. And it's really the basis for a zero trust architecture that says right down to the silicon, the customer is in control to be able to verify that the environment is untampered, and then no one has access to that data. Even if you do a memory dump with physical or virtual admin access, that data is only seen encrypted. And that's part of that innovation around encrypting the memory even while it's in use. We end up, Michael, you brought up that ML scenario around our preview with our NVIDIA confidential GPUs. This is just another one of our first to market innovations that we're pushing the needle in Azure. I believe we had another announcement at Build as well. It was part of Satya's keynote. Amr, do you want to give us some details on what we're doing in the container space, moving beyond just the virtual machines?
Yeah, absolutely, Graham. So there were a couple of notable announcements in Satya's keynote, as well as followed by Mark Russ demoing a product we built. So one is Intel SGX based confidential containers on Intel SGX, or what we call as confidential nodes within AKS. So you could take an existing AKS cluster or build a new AKS cluster and add DCSV3 VM SKUs and run your SGX apps at scale, right? So you can bring a container with the OSS wrapper and run your Java or Python, or you can even natively build SGX apps using SGX programming model, which plenty of customers do because they're in full control of every line of code that makes up your trusted computing base, right? So we extended that support with DCSV3 and the plugin that helps you to kind of focus on building on apps, and the infrastructure is all taken care of. The other product we are very excited is built on top of AMD SEV SNP. This is confidential containers on a serverless platform, Azure Container Instances. The best thing about this product is this is a fully managed serverless pay-as-you-go platform that is managed by Azure, and still gives you full lift and shift for your Linux containers. So you could take an existing container, existing Python app, existing Java apps, whatever you have, and bring it as is unmodified and run this and reach your confidentiality needs, right? We also support attestation capabilities because it's kind of a backbone to how you establish trust within your trusted execution environment. Right now, we're doing a private preview, and if you are interested, you could go to aka.ms/ccaci and sign up for the preview.
Awesome.
Thank you, Brent.
Yeah, no, that's very exciting. So the ability to bring your containers as is, leverage the quick burst for machine learning type workloads using this serverless infrastructure. Super, super exciting. We got a question in the chat from Lindsay about bring your own key scenarios. So Amr, let's use that container example there that says, hey, this is a managed service. We're doing all of the heavy lifting of owning the infrastructure and fully supporting it from the Azure perspective. You talked about customers being able to attest the environment. What about bringing their own keys and being able to make sure that they're fully in control of that data decryption?
Yeah. So just to make sure we set the right context here, right? There are keys that are used for encrypting your memory space, right? Those keys, Azure doesn't have access. Those keys, customers cannot bring their own memory encryption keys. These are generated from the chipset like Intel and AMD directly and issued to the virtual machines or the SGX enclaves. And those are the keys we are talking about, right? That's not, I'm hoping, is the question about. The question is also about, if the question is about the data decryption keys, where you have like a flat file or a CSV that is used for a data set that you want to train your ML model, you're bringing that from on-prem and you want to encrypt that with your own encryption key, right? So if that's the process, you could encrypt the key, encrypt with a key that is generated on-prem, or you could use our MHSM AKV product that is built also on confidential computing that allows you to have this. You use that as a data encryption key. You would upload the data there, and when you are in a trusted execution environment like confidential containers and ACI, uh, you could use that to securely release the key in a trusted execution environment. And we also have an added feature which is super cool. We call this a secure key unwrap or a secure key release. This allows you to only release the key to an attested trusted execution environment. That means your data and the keys are always within a secure space and operating in that. This functionality, we also have some abstractions in the product ACI that allows you to kind of seamlessly do this with some sidecar implementations that do all the heavy lifting to securely go do the attestation, bring the keys over, give the keys to your apps to just directly decrypt the data set you have and start training your ML model or even inference your ML model, for example. So this is the whole flow of how you could bring your own key. And we are not locking this into MHSM. You could as well extend this to your on-prem KMS or any other KMS solutions you want to do, where you want to securely kind of bind them together and use an attestation as an evidence before you get access to the keys.
That's fantastic. So it's the customer's not only in control of the environment, making sure that the environment is verified from the full hardware and software stack, but it's only once it's fully verified that the keys are even made available to start processing on that data if it's brought into the environment encrypted. Cool. So we're getting a question in the chat around PII data being hosted in memory engines, and around this memory encryption requiring processing. So I'm going to translate that question a little bit to understand what are the processing requirements of some of this encryption. If we think about the performance and the cost per se of the running data in this encrypted environment. Michael, do you want to just talk to us a little bit about the performance and just any added overhead?
Sure. Yeah. This is a great question and one that we hear quite a lot from our customers. Today, we have a premium in place for the SEV S&P from a price standpoint. For Intel SGX, it's effectively cost neutral versus a general purpose virtual machine. But what we're obsessed about is how do we work with the silicon providers to try and compress the encryption, the processing requirements for these new technologies. And if you look back to what it was like when we were just introducing data at rest and data in transit encryption, there was some overload in our some heavy processing that took place in the early generations, but over time that just, as the capabilities got better, you don't even think about it. With the generations that we have in market today, there's around a 2 to 3% performance overhead that customers have to take, which every day, myself and the team, we're trying to figure out ways with the upcoming products how we can reduce that further. Things that we think about is the time to boot your virtual machine. How do we compress that? What specific workloads that customers are running, and how do we take some of those particular applications and work with the providers to further compress. So it's around 2 to 3%. It does vary workload to workload, but that's a high focus for us to try and make that even better.
That still seems pretty fantastic, though, for a V1 product to be able to say, hey, 2 to 3% is not a lot. When we talk to customers looking for the security trade-off, they're in the range of 10 to 20% is okay, just to have the added security benefits. And Michael, if I understand what you're saying there a little bit, you're referring there's a difference between boot up time versus actual runtime processing. So one of the bits that I think you mentioned there was, there's that initial encrypt decrypt at boot up, which is where you might get that more noticeable overhead. But once things are in memory and processing, they're just processing like normal, right?
Yeah, absolutely. It's very minimal. We don't hear a lot of feedback from customers that it's a huge blocker. But yeah, again, with the upcoming generations, we're looking to further reduce that. And through some of the products that we have in market today, we're getting great feedback gen on gen. And also when comparing both products, specifically for AI workloads, in-memory relational databases, for example, that was discussed in the question, and other workloads.
Awesome. Well, this has been fantastic. I'm not sure we have time for any more questions. Just to give a little bit of recap, we do, and this is live TV. We had a lot of great announcements at Builds. Ultimately, in the Azure Confidential Computing space, we see confidential computing as a unique offering to be able to bring sensitive and private workloads to the cloud. Over time, we do see it becoming ubiquitous, where it's just computing. And the innovations that we're starting to see today with this memory encryption and level of customer in control of the environment to fully verify, that's what we see as being a future for all of Azure through our infrastructure and our services. Ultimately, thanks for joining us today. Head to the link below to see what's coming up next. Again, on behalf of the Azure Confidential Computing team, thanks very much. Let's see how we can bring all your workloads to the cloud and protect them with confidential compute.
Bye, everyone.
Bye.